to discuss about the basic types of measuring instruments. In electrical system, we can classify the basic measuring instruments in the following two types. First is voltmeter and the other one is ammeter. So let us discuss about these two basic measuring instruments in brief. So first of all, what is voltmeter? As the name suggests, the voltmeter is a device which is used to measure the voltage in any electrical circuit or the drop of the voltage drop in any electrical device. So as the name suggests, voltmeter is a measuring instrument which measures the voltage across any 2 points of an electrical circuit. The unit of voltage is volt and the instrument is a meter. So the word voltmeter is obtained by combining the two words volt and meter. So voltmeter is a device to measure the voltage in an electrical circuit, right? So there are two types of voltmeter, AC voltmeter and DC voltmeter. So this is a basic circuit diagram of a DC voltmeter. This is an analog DC voltmeter. So as we can see over here, there is a range of DC voltmeter from 0 to 10. It means that this voltmeter can measure a voltage drop in any electrical circuit up to 10 volt. Right? When we connect this DC voltmeter to any circuit in parallel in a circuit by these 2 points, then there will be a torque generated in this voltmeter, and that torque will start to move this needle in this direction. Okay, and if the voltage drop in that device where it is being connected is, suppose there is a 6 volt voltage drop over there, so this needle will stop at this 6. So by this we can measure the voltage drop in any load or in any electrical circuit by using this DC voltmeter. So similarly, an AC voltmeter is a voltmeter which measures the voltage in an AC circuit. So this is an AC voltmeter. Similarly, here is a range from 0 to 250 volt. So this voltmeter can measure a voltage up to 250 volt when it is connected in parallel with a circuit where we want to calculate the voltage drop in a load or in a circuit. Next we come to ammeters. So ammeter, as the name is suggested, ammeter is a device or an instrument which is used to measure the current in any circuit or in any electrical line. You need to connect this ammeter in series with that line where you want to calculate, where you want to know what is the basically amount of current that is going through that circuit, right? So as the name suggests, ammeter is a measuring instrument which measures the current flowing through any 2 point in an electrical circuit. The unit of current is ampere and the measuring instrument is meter. So the word ammeter is obtained by combining M from ampere and with meter. So ammeter is a meter which is used to measure the current in any electrical circuit, in any electrical path. So similarly, there are two types of ammeters, DC ammeter and AC ammeter. So DC ammeter is a device which is going to connect in a series with a DC circuit and which measure the current in that circuit. So this is the circuit diagram of a DC ammeter. So here this is a range of current that is going to be measured by this ammeter from 0 to 50 ampere. So this ammeter, this particular ammeter will measure the current up to 50 ampere. So if you are connected this ammeter in any load, in series with any load where you want to calculate, you want to measure the current, then this ammeter will be there will be a torque generated through this coil of ammeter, and this needle will start to move on this range, on this scale, and suppose this needle will stop at this 30. It means that the current that is going to be flow through that circuit, through that load is 30 ampere, right? So by this way we can measure the current in any electrical circuit by connecting this ammeter in the series of that circuit or in the series of that load. So similarly, an AC ammeter is the ammeter which is connected to in an AC circuit, in an AC load, and it will measure the current. The range of this ammeter, AC ammeter, is from 0 to 100 ampere. So it will measure the current up to 100 ampere. Now the question should arise in your mind that suppose the range of this ammeter is 100 ampere and you want to measure the current in a load in a circuit where suppose the current is flowing is up to 150 ampere. So what you should do, you should extend the range of ammeter or the range of voltmeter. So now we are going to discuss about how we can extend the range of ammeter. So the range of ammeter can be extended by a resistance that is going to be connected in parallel with that ammeter, which is called as shunts. So shunts are used for the range extension of ammeters. A shunt is a low value resistance having minimum temperature coefficient and is connected in parallel with the ammeter whose range is to be extended. So the combination is connected in series with the circuit whose current is going to be measured. So here we can see an example. Suppose a moving coil ammeter reading up to 1 ampere. Okay, so you are having an ammeter whose range is 1 ampere, who can read only up to 1 ampere. And the resistance of that ammeter is 0.02 ohm. This is the internal resistance of that ammeter. How could this instrument be adopted to read current up to 100 ampere? Suppose you are having a load, you are having a device where the current flowing is up to 100 ampere and you are having an ammeter which can measure only up to 1 ampere. So how can you extend the range of this ammeter to 100 ampere? So here we can see we will connect a resistance in parallel with that ammeter which is called as shunt, right? So full scale deflection of the ammeter is 1 ampere. The current to be measured is 100 ampere. Resistance of that ammeter is 0.02 ampere and the required shunt resistance is S suppose. So we need to find out the value of this S so that the range of this ammeter can be from 1 ampere to 100 ampere. So let us see how we can extend the range of this ammeter by connecting a resistance in parallel with that ammeter, right? So suppose this is the circuit diagram. There is a ammeter having 0.02 ohm resistance. This is the range of this ammeter is 1 ampere and this is the shunt resistance which is connected in parallel to this ammeter, right? So basically the main purpose of connecting this resistance in parallel to this ammeter is to providing a path to this extra current, because here there will be a load which is going to be connected and which is which carry the current like 100 ampere. So there should be a path. We are providing a path to this extra current, extra 99 ampere through this resistance which is called as shunt. So now we need to find out the value of this shunt resistance. So here we need to apply the constraints of the shunt of the parallel path. We know that in parallel path the current is going to be divided and the voltage should be same. So we know that the voltage drop of this ammeter and the voltage drop of this shunt resistance will be the same, right? So this phenomena we will apply over here to find out this value of shunt resistance. So here this is the voltage drop across this ammeter, that is Im into Rm, and this is the voltage drop across this shunt resistance, that is Is into S. So here we can write down Is as I minus Im by applying the KVL and by applying the KCL at this point, right? So if we apply the KCL at this point, we know that Is should be equal to I minus Im, or I should be equal to Im plus Is. So here we know that Is equals to I minus Im. So the value of S can be found out from this equation, that is Im into Rm upon I minus Im. So we know the value of Im, that is 1 ampere. We know the value of Rm, that is 0.02 ampere, 0.02 ohm. We know the value of I, that is 100 ampere. We know the value of Im, that is 1 ampere, right? So here we found out the value of S, that is 0.000202 ohm. It means that if this value of resistance is connected in parallel to this ammeter, to the given ammeter, then it will measure, the ammeter will measure the current up to 100 ampere. rather its range is only 1 ampere. So the range can be extended to 100 ampere from 1 ampere by connecting a resistance of this value 0.000202 ohm in parallel with that ammeter. So this is called as the extension range of ammeter. Similarly, the range extension of voltmeter, the range of voltmeter can also be extended by using a resistance which is called as multiplier. So we can connect a resistance in series with a voltmeter to extend the range of that voltmeter. Why we need to extend the range of that voltmeter? Since suppose we are having here again there is an example, a moving coil voltmeter reading up to 20 millivolt has a resistance of 2 ohms, right? So we are having a voltmeter having the reading or range of 20 millivolt. Now how this instrument can be adopted to read a voltage up to 300 volt? So we are having a voltmeter which is having the range or rating is only 20 millivolt, and we need to measure the voltage in a circuit or in a load which is up to 300 volts. So we need to extend our range from 20 millivolt to 300 volts. So let's see how we can do it. We will connect a resistance in series with that voltmeter. Okay, why we connect resistance in series? Because there is a phenomena in series circuit that the current will be the same and the voltage will be divided. So for this extra voltage we have 0.02 volt, the range of this voltmeter, and 300 volt is the voltage to be measured. So there is extra voltage. This extra voltage will be having a path through this resistance R. So this R is known as multiplier. So we need to find out the value of this resistance or the multiplier so that this voltmeter will be able to measure the voltage up to 300 volt. So let's see how we can measure the value of this voltage. So as in the case of ammeter, as in the case of shunt, we applied the concept of parallel circuit. The voltage in parallel circuit is same. So similarly in this here where we will apply the concept of series circuit, as the current in the series circuit will be same. So the current in this ammeter and the current in this multiplier will be the same. So the current in this is R into Im is equals to V minus V. Then we can apply the KVL equation over here. So V is the total voltage, V minus V is equals to R into Im, where R is the resistance of this multiplier and Im is the current going through this. So we know the value of Im, this is 0.01 ampere. We know the value of this V, that is 300 volt. We know the value of this small v, that is 0.02 volt. We need to only find out the value of this R, resistance. So here the value of R can be found out 29998 ohms. So here we can see that 29,998 ohms value of resistance can be connected in series with ammeter. It can be connected in series with this voltmeter to get the extended value of that voltmeter from 0.02 volt to 300 volt. So here we have completed the types of two measuring instruments, that is ammeter, voltmeter, and how we can extend the range of that ammeter and the voltmeter according to our application, according to our requirement. So in the next lecture we will discuss about the remaining two instruments, that is wattmeter, that is used to measure the power, and the next one is energy meter, that is used to measure the energy in any electrical circuit. So meanwhile, if you have any query, if you have any questions, if you have any requirement, you can drop a message to me.